Hello everyone, here is the video with the explanation and exploration of the result of our second milestone on ZK-fold UPLC converter, and let's start. So as was promised, we included both the prototype implementation and the comprehensive test suite for the prototype. Let's run it here. As we can see, all the tests pass. So, and let's examine what are we testing exactly. As we promised, we check that the result of the conversion of the UPLC term, of the closed UPLC term, and the corresponding arithmetic circuit are the same. So, for example, the first test checks that the return of the constant false function is a successful UPLC smart contract because it doesn't throw any error. So let's see. So the circuit has to return the success, the result of the operation, that it was successful. And here we see that there is a term which doesn't throw an error. Then the second one is that, well, the explicitly thrown the error term would throw an error, so it corresponds to the false circuit. Then we check simple substitution that it works. So here's the first TLM for the first argument of the UPLC version 3 contract, and we don't use it here. Then we just use a simple lambda function which accepts a single argument, and it is returned immediately. So, and as defined by the spec, we use the De Bruijn indices to refer to variables inside the terms. And of course, this is a circuit, this is a contract which executes just fine, so it returns true. So some testing of pairs, that the structuring of pairs, so we call the first pair and we try to run it on the usual pair, and this returns true, it's okay. Then we should try to run some destructuring function on something that is not a pair. This is a failure. Then we check that if works correctly, that it doesn't propagate errors on, for example, if then else the condition is true, but the else branch is error, it's still okay, so it's lazy. And then that if correctly propagates errors, that also we can execute higher order, execute functions which would be higher order if typed, but still we can convert them just fine. So for example, here if then else is an argument to the lambda function which accepts it and then uses it as the callee, so as the function which accepts 3 arguments, and this works just fine. It's okay. So let's look at the tests first. So how it works. We first in our same we accept the function which gets the term and returns the circuit. So it's the conversion algorithm itself. Second, we accept the term which we convert. Then we provide the last argument, which is the circuit, which should return the same result, and we'll just compare the results. How does the converter work? Let's see. So it just compiles one of the types of circuits, as you can see. So here we use the contract version 3, and this works by providing a single value to the function and then evaluating the function in context. How does functions look like? Let's see. So the functions are UPLC terms, which are described as described in the spec, in the specification of Plutus Core. So, and we have here everything which what do we need now and in the future. And well, basically that's it. We evaluate this term, and then we get the circuit, and then we check that it works fine. And this is it. Thank you for your attention.